Namaste learners. In previous lecture I explained physical world and scope, excitement of physics and more things. And today I am going to explain about the unit and dimension. Before I explain the unit, first of all I will explain the physical quantity. What is physical quantity? Physical quantity is those quantity which can be measured directly or indirectly and follow the law of physics. Only two things you must remember: the law of physics. The first is the law of physics and second is the measurement. Measurement and observation are the backbone of the physics. Observation and measurement. Observation and measurement. Two things are very important to understand physics. Okay, so this is physical quantity, and the second thing is unit. What is unit? Unit is the chosen standard of measurement quantity which has essentially the same nature. Same nature means if you want to measure the length, then unit chosen is centimeter, meter, feet and other units, and that is called same nature. That of the quantity is called unit of quantity. Chosen standard. This one is important. Chosen in the standard and the measurement of a quantity. This is called the unit. Generally, physical quantity is of two types. On the basis of magnitude and on the basis of magnitude and direction. On the basis of magnitude and direction, and on the basis of nature. Okay. Then on the basis of magnitude direction, we will learn the first is a scalar, has only magnitude and more explanation needed, and vector simply magnitude and direction, both magnitude and direction. I will explain later on this. And third is tensor quantity. These all are explained later. Nature. On the basis of nature, there are two types. Nature or somewhere it is also on the basis of origin. Fundamental physical quantity. Fundamental physical quantity, and second is derived physical quantity. The two things. Fundamental physical quantities are those which are independent of other physical quantities, which do not depend upon the any other physical quantity, is called fundamental physical quantity. Fundamental physical quantity are those quantities which are independent of other. Generally, mass, length and time. Generally, mass, length and time are considered as fundamental physical. Fundamental is also called basic. Fundamental. It is sometimes called basic. And mass, length and time are fundamental physical quantity, and more, just like current, electricity. Current, electricity is also fundamental. Mole of substance. Temperature is also temperature. Mole of substance. The amount of substance, and one more is luminous intensity. Okay, these are the fundamental quantities, and except these all known as derived physical quantity. Except these known as the derived physical quantity. Means derived physical quantity depends upon the other physical quantity. As for example, mass, and one thing also, unit. The unit of fundamental physical quantity is called fundamental unit. This is called fundamental unit, and derived equal derived unit, fundamental unit. fundamental unit. As for example, units are also one or two system, just like CGS system, FPS system, MKS system. Okay, CGS centimeter gram second system, foot pound second system, meter kilogram second system. Mass in CGS system, mass is represented in gram. And in FPS it is pound. Mass in CGS system is gram. This is the gram. In FPS pound, and in MKS kilogram. Length is CGS centimeter. FPS is the feet, and this is the meter. And time is second. Here is also second. Here is also second. You may use abbreviation as a G, simply G, and this is the pound, LB. This is kilogram. Then full form is kilogram, and you may write meter, and these all about the second. And this is the centimeter. This is the foot. Plural feet, foot. And all other physical quantities, just like luminous intensity is candela, but these are explained in SI unit. And derived unit are those units which are derived unit means it's just like a force. Force is equal to mass into acceleration. This is the mass is fundamental, but acceleration is not fundamental. Then mass into velocity by time. Again velocity is derived. Derived means velocity is also derived. Velocity is derived by the displacement by time. Displacement is fundamental and time is fundamental. And velocity is derived because it is derived from the displacement and time, and that is why it is called derived physical quantity. Derived physical quantity means the quantity which can be derived on the basis of fundamental quantity is known as derived physical quantity. A fundamental quantity is those quantity which are independent of the other. दूसरे पे डिपेंड ना करे, तो फंडामेंटल जो दूसरे पर डिपेंड करे उसे क्या कहते हैं, डिराइव्ड. जो दूसरे पर डिपेंड ना करे, फंडामेंटल जो दूसरे पर डिपेंड करे वो होता है डिराइव्ड. SI unit. These are the seven and two are supplementary. 7 means mass, length, time, temperature, current, electricity, amount of substance, luminous intensity. These are the SI unit. SI unit mass is kilogram, symbol is kg, and length is meter, then it is m, time is second, it is s, and temperature is Kelvin, K, and current electricity is ampere. Ampere should be written with a small letter, and symbol is capital M. Amount of substance is mole, also written as mole. Luminous intensity candela, symbol is CD. And definition of these all are available in your basic book NCERT. It's textbook. You may read and learn the definition of these all physical quantities. And two supplementary unit. Two. One is the plane angle. As you know, this is the ray, this is the angle, or this is the arc, this is the length arc, and this point O and this point something is A, then arc. Angle equal to arc by radius. and its SI unit is radian. This is the radian. Abbreviation also may write radian. And 180 degree is equal to pi radian. 180 degree is equal to pi radian. This is the supplementary of SI unit. And second is the solid angle. Solid angle. This is, suppose the angle is like this, and this is the, suppose this part, this angle is covered, this angle is called delta omega, and delta omega is equal to area by distance r square. Delta omega is equal to area by r square. Where is area? There is r. The area is covered. This is the delta, this is the angle, and suppose this is the angle inside. This one is the, suppose this one is put here, and just something is on this, then area covered by this surface, and distance from this and this, means the distance from somewhere O, or suppose this is the R1, suppose in here this is the area and this is the R, this is the R, or this is the area ds, then becomes delta omega. This is called solid angle. The angle of inner side angle, ring, this one is the angle, is called solid angle. This is the solid angle. Is macrocosm. Macrocosm means large distances. The distances large. Macrocosm. Astronomical unit. The average distance between sun and earth is called astronomical unit. The average distance between earth and sun. Actually, the time taken to reach the light from sun to earth is approximate 8 minutes 20 seconds, 20 or 23 seconds. And you may calculate the distance s equal to ct and equal to 3 into 10 to the power 8 meter per second, and 8 minutes and 23 seconds, these ones. And it may becomes 9, just like this astronomical unit, 1.496 into 10 to the power 11 meter, and approximate is equal to 1.5 into 10 to the power 11 meter. This is called the astronomical unit. The average distance from sun to earth is called astronomical unit. The second thing is light year. Light year is the distance traveled by light in 1 year. Distance covered by light in 1 year. Distance traveled by light in 1 year. Means again I am using the formula S equal to ct, 3 into 10 to the power 8 meter per second, and the time is 1 year, and you may change. This one is the distance, 1 light year is equal to 3 into 10 to the power 8 into 365 days, 624 hour, 60 minute, 60 second, and if you multiply these all numbers, then you will get 9.46 into 10 to the power 15 meter, which is approximate equal to 9.5 10 to the power 50 meter. This is the light year. Light year is the average distance from the light year is the distance traveled by light in 1 year. You may write or you may calculate the relationship between light year and astronomical unit. Suppose 1 light year by 1 astronomical unit is equal to 9.5 into 10 to the power 15 meter by 1.5 into 10 to the power 11 meter. this one. If you divide this, then you get the value approximate equal to, just like a relations I have written here, 1 light year and 1 light year and astronomical unit. 1 light year is equal to 6.3 into 10 to the power 4 astronomical unit, and similarly this is the arc. The length of arc is 1 astronomical unit. Suppose, and this angle is 1 second. This angle is 1 second. And the distance from here to here is called 1 parsec. This is called 1 parsec. Okay? Then simply, if we want to find the value of O to A means 1 parsec. 1 parsec is equal to radius. Then angle equal to arc by radius. And if you want to find the value of radius, then you must divide arc by angle. And arc is 1 astronomical unit. And angle is what? Angle is 1 second. Angle is 1 second. This is very important. Then in class 11, 1 or 2 questions are asked from this topic unit, and one is most important question is conversion of 1 second into radian. Conversion of 1 second into what? Radian. You must remember how it is converted. As you know, 180 degree equal to pi radian. 180 degree equal to pi radian. Then 1 degree is equal to pi upon 180 radian. In 1 degree there are 60 minutes. 1 degree is equal to 60 minutes. And 1 minute is equal to 60 seconds. Then 1 degree equal to 60 minutes. 1 minute equal to 60 seconds. This is the minute. This is the minute, or this symbol for second. Okay, single line, minute, and double line, second. 1 degree equal to this, then 1 is 60 minutes into 60 seconds. This becomes second, or equal to pi upon 180 radian. And therefore 1 second is equal to pi upon 180 into 60 into 60. This is the conversion of 1 second into radian. This value 1 second into radian. Now you may put the value, means 1 parsec is equal to 1 parsec, 1 astronomical unit, which is equal to 1.496 into 10 to the power 11 upon pi by 180 into 60 into 60. You will get the value of 1 parsec is equal to 3.1 into 10 to the power 16 meter. You can find the value of these things. There is no need here. This is very simple. You can solve and find the value of 1 parsec. This is the 1 parsec. Just like this one, may I 1.496 into 180 into 60 into 60 by into 10 to the power 11 also by pi means 3.14. Just like you first of all select the number 1.496 into 18 into 36 by 3.14 into 0, the 1, 2, 3 and this one is the 14. It becomes 14, and that's why after the calculating this value it becomes 3.1 into 10 to the power 16 meters. You may solve 2 questions. Find relation between parsec फर्स्ट में पार्सेक एंड लाइट ईयर, सेकेंड parsec and astronomical unit. Which one is greater, which one is lesser, you may find by the dividing two units. And now some small distances. A small distance is just like a micron. Micron means 10 to the power minus 6 meter. Nano, 1 micron. Micron is unit. Nano, 10 to the power minus 9. 1 nano, 10 to the power minus 9 meter. 1 Fermi is equal to 10 to the power minus 15 meter. And this value you must remember as a unit of a small. 1 angstrom is also 1 angstrom. 1 angstrom. 1 angstrom is equal to 10 to the power minus 10 meter. And it is represented as a something this. And one more thing is prefix. Prefix. Pre means पहले, किसी यूनिट के जो पहले आ जाए उसे प्रीफिक्स कहते हैं. जैसे सेंटीमीटर, डेकामीटर, डेसीमीटर. डेसी इज प्रीफिक्स, सेंटी इज प्रीफिक्स, किलोग्राम, किलो इज प्रीफिक्स. Okay, and sometimes during the conversion of one unit to other unit, a students confused, and that's why I will explain the prefixes. This is the symbol, just like a prefix. Prefix is deci, centi, milli, micro. 1 minute. Deci, centi, milli, micro, nano, pico, femto, atto, deca, hecto, kilo, mega, giga, tera, peta, and etc. This one. Deci D, centi C, milli M, micro means mu, nano N, pico P, femto F, atto A, deca D, hecto H, kilo K, mega capital M, giga capital G, tera capital T, peta P, exa E. This is prefix, this is symbol, and this one is the value. Value means deci 10 to the power minus 1, centi 10 to the power minus 2, 10 to the power minus 3, 10 to the power minus 6, 10 to the power minus 9, 10 to the power minus 12, 10 to the power minus 15, 10 to the power minus 18. And you just remember as a song, deci, centi, milli, micro, nano, pico, femto, atto, deca. And deca, from deca it becomes, the difference is 1 2 3, difference is 3 3 6, 6 3 9, 9 3 12, 12 3 15, just the difference of 3, and you just count 3 continuously, and from here it becomes positive. Deca 10 to the power 1, hecto 2, 10 to power 3, mega 10 to the power 6, giga 10 to the power 9, tera 10 to the power 12, peta 10 to the power 15, exa 10 to the power 18. Actually this one is the 1 by 10, this one is the 1 by 100, this one by 1 by 1000. This is more, there is no need to further explain. 10, this one is the 100, this one is the 1000, and you know. And what is the use of this prefix? Now, use of this prefix. Suppose that someone asked in question, how many meter in 1 centimeter? In 1 centimeter, in how many meters? Then how you find? Then centi prefix. Centi is the prefix. Centi means 10 to the power minus 2. It means meter. In C is centi, centi is 10 to the power 2 minus meter, then it becomes 1 centimeter is equal to 1 by 100 meter. The other usage, someone is asked 1 millimeter is equal to how many centimeter, in 1 millimeter equal to how many centimeter, then 1 millimeter is equal to 10 to the power minus 3 equal to 10 to the power minus 3 meter, and you may write minus 2 meter into 10 to the power minus 1, then 10 to the power minus 2 is centimeter, then it becomes 10 to the power, just you think about this is the centimeter and this is called centimeter, this becomes centimeter. Then suppose someone asked you in how many centimeter in 1 millimeter, just write 1 millimeter, value of 1 millimeter, convert the numericals value as you want. One more example, suppose someone asked how many 1 decameter is equal to how many millimeter, 1 decameter is equal to how many millimeters, then just you write decameter or 1 millimeter, then 1 millimeter is equal to 10 to the power minus 3 meter, but here is decameter and there is no value of deca, then you put value of deca as denominator and numerator of deca. Deca means 10, then multiply and divide by 10, and 10 meter is decameter. This one is the 10 meter is decameter. Which one? This one is the 10. 10 meter is decameter. Then just write the 10 decameter. 10 decameter. And the value of this is, this one is the decameter. The value of this is decameter. This one is the decameter. Decameter. And the numerical value becomes 10 to the power minus 3 and becomes 10 to the power minus 4. Means 1 millimeter is equal to 10 to the power minus 4 decameter. Okay? And once again you write the value 1 decameter is equal to how many millimeter. Then 1 decameter means 10 meter. And I don't know about the milli, then you multiply and divide by 10 to the power minus 3. And 10 to the power minus 3 becomes millimeter. This becomes millimeter. This becomes millimeter. And the value of this is becomes numerical value, means 10 to the power minus 10 and becomes 10 to the power 4 millimeter. Means 1 decameter is equal to 10 to the power 4 millimeter. I will reverse. 1 millimeter is equal to 10 to the power minus 4 decameter. Now one more and last example. Suppose you want to convert 1 milligram to just hectogram या kilogram, more famous kilogram, milligram to kilogram. As you know, 1 milligram is equal to 10 to the power minus 3 gram, and you want to convert kilogram. Okay, 1 kilogram is equal to 10 to the power 3 gram, and the question is how many kilogram in 1 milligram. So 1 milligram is equal to 10 to the power minus 3 gram. 10 to the power minus 3 gram, and we have no value here 10 to the power 3. Just you multiply and divide the value required. The value required is this, then 10 to the power 3 and 10 to the power 3 is multiplied and divided, and this is the kilogram. This is the kilogram, and just put the value, just 10 to the power minus 3 and minus 3, this becomes kilogram, means 10 to the power minus 6 kilogram. Means in 1 milligram there is 10 to the power minus 6 kilogram. Just you check it. check it. How I can check? 10 to the power minus 6 gram and 10 to the kilo means 10 to the power 3 gram. Then again it becomes 10 to the power minus 3 plus 3 is equal to 10 to the power minus 3 gram. Or this is the milligram. This is the milligram. I hope you understand the use of prefix. And now I am going to start the new topic, dimension. This is the few rules to write unit. The first rule is first letter of unit is always in a small letter. Means किसी साइंटिस्ट का भी नाम अगर हो तो न्यूटन जो है हम लोग न्यूटन को ऐसे लिखेंगे, अगर ये सही है। लेकिन कोई बंदा अगर ऐसे लिखता है न्यूटन तो ये गलत है। सपोज दैट आप अगर जूल लिखते हो ऐसे तो ये सही है, लेकिन कोई अगर जूल ऐसे लिख दे यूनिट में तो ये गलत है। ठीक है, ये ध्यान रखिएगा कि न्यूटन द फर्स्ट लेटर शुड बी अ स्मॉल लेटर एंड यूनिट नेवर इन प्लूरल फॉर्म। मीन्स किलोग्राम्स लिखना गलत है, 10 किलोग्राम लिखना सही है। दिस इज द रूल, ग्रामेटिकल रूल, इट इज नथिंग ओनली ग्रामेटिकल रूल। पंक्चुएशन मार्क्स आप नहीं दे सकते हैं। जैसे क्यूबिक सेंटीमीटर है तो क्यूबिक सेंटीमीटर में ये देना गलत है, ये सही है। एंड ऑलवेज लीव ए स्पेस, हाँ ये बहुत जरूरी है, स्पेस आप देंगे। जैसे आप लिखते हो सेंटीमीटर तो सेंटीमीटर ये प्रीफिक्स है और ये यूनिट है तो यहाँ स्पेस की जरूरत नहीं है। लेकिन अगर आप स्पेस देते हो तभी इसको पढ़ेंगे, ये स्पेस नहीं देते हैं तो इसको हम लोग पढ़ते हैं सेंटीमीटर। लेकिन अगर आप स्पेस दोगे तो इसको हम लोग पढ़ेंगे कूलम्ब मीटर। कूलम्ब मीटर। One thing here is small letter because Coulomb is a name of scientist. And next, avoid use of more than one solidus. एक solidus क्या होता है? जैसे आप लिखते हो कि F equal to G_m1 m2 by r square. Then G equal to क्या लिखोगे? F r square by m1 m2. ठीक, तो आप लिखिए न्यूटन मीटर स्क्वायर बाई क्या किलोग्राम स्क्वायर। तो ये सॉलिडस हुआ। जैसे आप लिखते हैं ना कि न्यूटन मीटर स्क्वायर बाई किलोग्राम स्क्वायर, तो इसी का नाम है ये जो आप देख रहे हो, दिस इज कॉल्ड सॉलिडस। तो एक से ज्यादा सॉलिडस हम नहीं देंगे, ये ध्यान रखिएगा। एक से ज्यादा, जैसे मान लीजिए ऐसा फिजिकल क्वांटिटी आया कि केजी मीटर स्क्वायर और एक और यूनिट आ गया, मान लेते हैं कोई टेम्परेचर का केल्विन का स्क्वायर आ गया, ऐसे नहीं लिखेंगे कि केजी पर मीटर स्क्वायर पर केल्विन स्क्वायर, ये लिखना गलत है। अगर हमको लिखना ही है तो हम ऐसे लिखेंगे इसको, इसके बदले में हम ऐसे लिखेंगे कि केजी पर मीटर स्क्वायर, थोड़ा डैश दीजिए और तब इसको लिखिए केल्विन स्क्वायर। सॉलिडस एक ही इस्तेमाल होगा, एक से ज्यादा सॉलिडस का इस्तेमाल नहीं होगा। कुछ और भी रूल्स है जो हम पिक्चर में लगा देंगे, वीडियो में के पिक्चर में कहीं कहीं सेट कर देंगे। डायमेंशन का भी कुछ पार्ट होगा जो हम लगा देंगे, क्योंकि हर पॉइंट को एक्सप्लेन करना उचित नहीं है, तो इसको आप लोग याद रखेंगे। The power raised on fundamental physical quantity is called dimension. Just like m, l and t, mass, length and time, and the power abc is called dimension. abc, the power ab and c are called dimension. And this is called dimensional formula. And if some physical quantity x, then this becomes dimensional equation. This is the dimensional formula. And this becomes dimensional equation. Whole dimensional equation. This is the dimensional formula. This is whole is the dimensional equation, and a, b and c is called dimension. How we find the dimension? Just like force. Okay, force. Then force is equal to, formula is mass into acceleration. Mass into acceleration. Then as mass is m, acceleration is again velocity by time. Okay, and this becomes, mass is fundamental and time is fundamental, that's why it is m by t. But velocity is again derived and it converts in length or distance, displacement by time. And now these all are the fundamental quantity, that is called ml by t into t, or it becomes mlt inverse 2. And you must just enclose from the square bracket. Dimensional formula is enclosed in a square bracket. It is necessary. It is rule. This is the dimension of force, mlt minus 2. If you want to find the dimension of work is equal to force into displacement. Then just you find the value of force, then mlt minus 2, then L into L square, then it becomes ml2 minus t. And if you want to find the dimension of power, the power is equal to work by time, and this is work is ml2 t minus 2 by time again, then it becomes ml2 t minus t. There are so many physical quantities. 94 physical quantities are given in last page of volume 1 NCERT. 94 dimensions. Okay, then and in some other books it becomes 100 and more. And how many dimensions you learn, this is very problem. Then I give you few dimensions. With the help of these dimensions you can find all dimensions of the physical quantity. Just learn by heart. Learn by heart these dimensions. First of all, mass, length, time, temperature. Actually mass, length and time, and other is the current electricity. Current electricity. Mass is m, length is l, time is t, current I or a, both are used. Okay, and then area, a square, dimension of area, a square means l square, and volume is l cube, density is ml minus q, and pole strength is il, charge is it, and one is velocity, displacement or distance is l, velocity is lt minus 1, acceleration is lt minus 2, force is mlt minus 2, and work is mlt. Either energy or either torque, ml2 t minus 2. And more thing, just wait further. These physical quantities are very important to derive the dimension of other physical quantity. As for example, universal gravitational constant is more common. Universal gravitational constant, capital G. As you know, F is equal to G m1 m2 by r square, gravitational force. Okay, I taught in first chapter. And this becomes G equal to F r square upon m1 m2. As you know, F is mlt minus 2, then here you may write mlt minus 2, r is distance, then l square, and m is mass, then m and n, 1m cancel out, then 1m minus 1, l cube, and t minus 2. you can easily find the value of capital T. You may find the dimension of resistance. Resistance is equal to V equal to IR. But here is R is equal to V by I. And the formula you have learned in 10th class, the work done is equal to QV. Q means charge, V means potential. This is the charge, this is the charge, or this is the electric potential. Okay? Then this is the electric potential. Then V equal to W by Q. Just here W by Q into I. And W is, I have written here ml to T minus 2. Then you put here ml to T minus 2 upon Q. Q is IT and this is the I. And this becomes, the dimension of this is L square, and T is here also I square, and this is T, ml to T minus Q I minus 2. This is the dimension of R. Dimension of R is equal to V by I. V means W equal to Q. V equal to W by Q. Then this is the W by Q. Q is the charge. Charge is IT, and this is the I. Okay. Then this becomes I inverse 2, and T goes in numerator, and it becomes T minus Q. Then ml2 T minus Q I minus 2. This is the dimension of resistance. Means all physical quantities can be found with the help of 1 to this approximate 14. Only 14 I have provided you dimension of this physical quantity. You learn by heart and derived the 94. Your homework or class work as you wish. Homework is 94 dimensions. Write 94 dimensions of NCERT. Write 94 dimensions of NCERT book. And last page of NCERT, first volume. But you must remember that don't write directly dimension. You go through this with the help of these dimensions. You must go with these dimensions and solve as like this. And you just writing the dimensions, it is not necessary. It is not beneficial. If you will do as like this, putting the value of A, first of all you write the formula, and after writing the formula you just write the left side unknown values, and just putting the dimensions of your given physical quantity, you can find the dimensions of other. One more example I will explain. One more example. Just like a universal gas constant. Universal gas constant. It is equal to known as R. Universal gas constant. Universal gas constant. PV equal to nRT, very famous formula. PV equal to nRT. And you may, PV is also work. Then PV, work, energy, torque, all the ml minus 2. And we want to find dimension of R. Then R, PV by what? NT. P is pressure. Pressure is force by area. Force by area into volume into 1 by NT. And volume, as you know, area into length is called volume. Then 1 by NT. Then T means temperature here. T means temperature. Force, area cancel out. Then force is mlt minus 2 into L into 1 by N means mole. Your choice, you may write or not. And this is the Kelvin, K. And it becomes ml2 T minus 2 and per mole per Kelvin. This one is the dimension. Someone it is not written because this is the unit and this is not considered in dimension. Then ml2 t minus 2 k inverse 1, and I am written here. Then ml2 t minus 2 per mole per Kelvin. This is so easy, and you can find very easy. Every physical quantity can be derived by this. Now I am going to explain different types of variables and constant. The first is dimensional variable. A physical quantity just like a velocity, force, acceleration, these all are variable and having dimension, and hence it is called dimensional variable. Something is dimensional constant. Dimensional constant means a physical quantity having fixed value, just like a gravitational constant, universal gas constant, and Planck's constant. These all are having dimension, known as it is called dimensional constant. And third is non-dimensional variable. Non-dimensional variables are those which has the variable quantity, as like a strain. A strain is equal to change in length by length, then it is dimensionless. And angle is also the ratio of arc by radius, hence it is also dimensionless. In those physical quantity which has constant value but dimensionless, and hence it is called non-dimensional variable. And the fourth one is non-dimensional constant. Non-dimensional constant. Non-dimensional constant, a constant which has no dimension, as for example pure number, pi, and e exponential value. These are trigonometrical values are also variable, but here is pure numbers, pi, and exponential value, constant. These all are dimensionless. Okay. Now I am going to explain about the uses of dimension. What is the use of dimension? The first thing is to check the correctness of a physical equation, or this is also called principle of homogeneity. It is also called. it says each and every term of physical equation had same dimension. This is very important. Dimension. Just for example, a is equal to ut plus half at square. Okay, and this value is a is equal to ut plus half at square. Means the term is ut and at square, these all are having same dimension. S is dimension of L, and it may write is m0 L t0, and the power of anything is 1. That's why I am writing in this way. And this is the next is ut is lt minus 1 into t. It becomes also m0 t0. And the last one is at square. At square means a lt minus 2, and this is the t square. It becomes again m0 lt minus 0. Then dimension of s is equal to dimension of ut is equal to dimension of at square. Means these three physical quantity terms having the same dimension, hence this equation is right. Otherwise, if it is not equal, the given physical equation may wrong. But sometimes a is equal to ut plus 1 by 8 at square. Then this equation is also dimensionally correct. But in use, but numerically wrong. Yeah, applicable but numerically wrong. Then one conclusion came after this example. Which conclusion? Conclusion is this: a dimensionally wrong equation cannot be correct. A dimensionally wrong equation cannot be correct. But dimensionally wrong equation cannot be correct. But dimensionally correct equation may be wrong. जो डायमेंशन से चेक करने के बाद अगर वो सही हो जाए तो हो सकता है कि वो गलत हो, लेकिन अगर डायमेंशन से कोई कह दे कि ये गलत है तो वो सही नहीं हो सकता है. दिस इज द बेस्ट यूज ऑफ डायमेंशन. एंड द सेकंड यूज इज टू डिराइव द रिलेशन बिटवीन डिफरेंट फिजिकल क्वांटिटीज. यस, we can derive a physical equation with the help of dimension of physical quantity. And for example, use number 2. V is velocity of sound, and this V depends upon modulus of elasticity of medium and density of medium. Rho is density of medium. It represents, and E is modulus of elasticity of medium. These two things means velocity of sound depends upon two things. Velocity of sound depends upon E and rho, and just equate this is the constant E and rho, and A and B, power A and B. Write the formula of each one. Means E is elasticity, means a stress by a strain. This is the stress by a strain. A stress is force by area, and a strain is change in length by length, and it has no dimension, and that's why it becomes mlt minus 2 by L square, it becomes ml minus 1 T minus 2. And this is the density. Density is mass by volume, it becomes ml minus q. Then just write the formula LT minus 1 K ml minus 1 T minus 2, and this one is A, and rho is ml minus q, ml minus q, and power is B. And just you write all these things. Just here m, here is also m, that why m A plus B. Okay, and this is also L. L is here L, and here is also L. Then write L minus A or minus 3B. The power is 3B. And finally, 1 is the T. T is T minus 2A. And then compare M0 LT minus 1. M is 0. Then A, compare the power of common base. Compare power of common base. Of common base means A plus B is equal to A plus B is equal to 0. Equation number 1. And you start with this T. T equal to what? T, the power of T is minus 1, means minus 2 equal to minus 1, then A equal to 1 by 2. Therefore, B equal to minus A, then it becomes minus 1 by 2. And putting the value of A and B in equation 1, putting the value of A and B in equation 1, we will get the value of velocity. V is equal to K, and E to the power A means 1 by 2, then 1 by 2, and rho is minus 1 by 2, then it becomes minus 1 by 2. Then formula of V becomes V equal to E by rho under root power, and this is the K. This is the formula of velocity of sound. Then the second use is we can derive the relation between different physical quantities involved in a physical phenomenon. This is 1 and 2 more examples of this method. And I again prove the simple pendulum, time period of simple pendulum. Suppose that. Second example, time period of simple pendulum. T is time period of simple pendulum. Time period of simple pendulum. Simple pendulum. Simple pendulum is just a thread and bob system. This is called simple pendulum. The mass is m, length is l, and this is to and fro motion is called oscillatory motion. Then this time period depends upon L by the experiment. It comes from the experiment. T is directly proportional to L and T is directly proportional to G. There are two things, L and G. And by the equation 1 and 2, we can write this. And proportionality is L and G. Then you consider a value A and B. As you know, time is m0 L0 T and T1. K is constant. L means length. Then dimension is also L. Then it is G LT minus 2. Then power becomes 2. Power becomes LT minus 2. Then power is B. Now value is here is m0 L0 T1 is equal to K. Here is L A plus B. Here T minus 2B. Just compare the power. Compare means M is here is M, but here is also m0. There is no need to write. And here is A plus B. Then A plus B is equal to 0. Equation number 1. And the second thing is minus 2B. Minus 2B is equal to 1. then minus 2b is equal to 1, then b equal to minus 1 by 2, and therefore a is equal to minus b, then 1 by 2, and therefore from this equation, from equation 1, we can write time period is equal to k L to the power 1 by 2, and power of g is minus 1 by 2, and it becomes k under root L by g. Another example of derivation of formula. This is the formula of time period. This is limitation k. Limitation, the pure number is not calculated by the dimension method, and the original formula is 2 pi under root L by g, and that's why numerical value cannot decide by the dimensional method. This is the limitation of dimension. Here is the topic. It gives no any information about pure numericals. The dimensional analysis cannot be used to derive a relation in the physical MLT. अगर वो MLT पर है, MLT को लेके चल रहा है कोई फिजिकल क्वांटिटी, तो आप उसको डिराइव कर सकते हैं. MLT अगर नहीं है तो डिराइव नहीं कर सकते हैं. और उसके बाद एक रिस्ट्रिक्शन भी है कि पावर वगैरह रहेगा जो भी है, उसको हम लोग डायमेंशन मेथड से नहीं फाउंड कर सकते हैं. तो कुछ तो है जो हम लोग डायमेंशन से कर सकते हैं, बहुत सारा नहीं भी कर सकते हैं. लास्ट यूज, थर्ड यूज, आई एक्सप्लेन लिमिटेशन, दैट्स व्हाई आई रब इट, एंड द थर्ड यूज इज conversion. Suppose that you want to convert 1 Newton means how many times? Newton is the SI unit of force. This is the SI unit of force, and this is the CGS unit of force. CGS unit of force. And I want to convert SI to CGS. And for this, a physical quantity is Q, and it is the numerical value and unit. This is the numerical value, and this is the unit, and always constant. Suppose that 1 meter is equal to 100 centimeters. Then length of something is 1 meter. It also called 100 centimeter. That's why n1 u1 equal to n2 u2. Just you write n1 u1 equal to n2 u2. Then 1 Newton equal to how many times? This is the n1, this is the u1, and here is n2 is not known, and u2 is this, and n2 is equal to n1 into u1 by u2. And how dimension helps here? The dimension, as you know, it is a force. This is a force, and that's why dimension is MLT minus 2. M means kilogram, this is meter, or this is second minus 2. This one N1 is 1, U1 is kg meter per second square. In CGS it is gram, it is centimeter, it is second minus 2. And then this is the kilogram, then gram, this is the centimeter, this is second minus 2. Second minus 2 and second minus 2 cancel out. Then finally this one cancel out. Then 1000 gram by gram into 100 centimeter by centimeter, then it becomes 10 to the power 5. Then final answer is 1 Newton equal to 10 to the power 5 time. Then your work is how many earth, 1 joule equal to how many earth. You can find the value of. This is the SI unit of work, and this is the CGS unit of work done, and you convert easily. And this is all about the dimension. You see in description I mention many things, or one photograph I attach with this equation for the for informing you how many physical quantities has the same dimension, just like a work done, torque, and PV. These all are having same dimension, and there are 14 or 15 list I have, and just photo mention in video. Just you screenshot and learn it. Okay, thank you.